Download this code from codegive.com, link in the description below. Allowing users to access an S3 bucket with AWS KMS encryption, a detailed tutorial. This tutorial will walk you through the process of granting users access to an S3 bucket that uses AWS Key Management Service, KMS, for encryption. We will cover everything from creating the necessary resources, S3 bucket, KMS key, IAM roles/policies, to testing the setup and understanding the underlying security principles. Why use KMS encryption for S3? Before diving in, let's understand why you might choose KMS encryption for your S3 buckets. Enhanced security. KMS provides centralized control and management over your encryption keys. This makes it much easier to enforce security policies and rotate keys regularly. Auditability. KMS logs all key usage events, giving you a detailed audit trail of who is accessing your data and when. Compliance. Many compliance regulations, example HIPAA, PCI-DSS, require encryption of data at rest, and KMS can help you meet these requirements. Integration with AWS services. KMS is seamlessly integrated with other AWS services, making it easy to encrypt data stored in S3, EBS, RDS, and more. Prerequisites. AWS account. You'll need an active AWS account with appropriate permissions to create S3 buckets, KMS keys, and IAM roles/policies. AWS CLI. The AWS command line interface, CLI, is highly recommended for managing AWS resources. Install and configure it with your AWS credentials. Basic understanding of AWS IAM. Familiarity with IAM roles, policies, and permissions is essential. Steps. 1. Create a KMS key. The first step is to create a KMS key that will be used to encrypt and decrypt objects in your S3 bucket. Using the AWS CLI*. This command creates a symmetric KMS key with the encrypt_decrypt usage. A symmetric key is generally recommended for S3 encryption. The customer master key spec parameter defaults to symmetric_default in newer AWS regions. The -tags option adds a descriptive tag. Using the AWS Management Console. 1. Navigate to the AWS KMS console. 2. Click on Create Key. 3. Choose Symmetric Key Type. 4. Enter an alias for the key, example alias/S3 encryption key. Aliases make keys easier to identify and manage. 5. Add optional tags. 6. Define key administrators, IAM users or roles who can manage the key. 7. Define key users, IAM users or roles who can use the key for encryption and decryption. We'll configure this in more detail later. 8. Review and create the key. Important *. Note the key ID, example 1234 ABCD 12 of 34 CD 56 F123456789 OB, and the ARN, Amazon resource name, example ARN AWS KMS US East 1:123456789 key/1234 ABCD 12 of 34 CD 56 F123456789 OB, of the KMS key. You will need these later. 2. Create an S3 bucket *. Now, create the S3 bucket that you want to protect with KMS encryption. Using the AWS CLI*. Replace your unique bucket name, us east 1 and arn AWS KMS us east 1 colon 1 2 3 4 5 6 7 8 9 0 1 2 key slash 12 34 ABCD 12 of 34 CD 56 F 1 2 3 4 5 6 7 8 9 0 of with your actual bucket name, region, and KMS key arn respectively. Asterisk using the AWS Management Console asterisk. 1. Navigate to the S3 console. 2. Click on Create Bucket. 3. Enter a globally unique bucket name. 4. Select the AWS region where you want to create the bucket. 5. In the default encryption section, select server-side encryption. 6. Choose AWS Key Management Service Key, SSEKMS, as the encryption key type. 7. Select the KMS key you created in the previous step. 8. Configure other bucket settings as needed, versioning, access logging, etc. 9. Click Create Bucket. 3. Create an IAM role for users asterisk. Create an IAM role that users will assume to access the S3 bucket. This role will have the necessary permissions to interact with S3 and use the KMS key. Asterisk create a trust policy asterisk. Create a file named trustpolicy.json with the following content. This allows IAM users to assume this role. Replace your _account _ID with your AWS account ID. Asterisk create the IAM role, using AWS CLI. Asterisk using the AWS Management Console asterisk. 1. Navigate to the IAM console. 2. Click on Roles and then create role. 3. Select AWS account as the trusted entity type. 4. Enter your account ID. 5. Choose the Allow users in this account to assume this role option. 6. Click Next. 7. On the Add Permissions page, we will define the permissions in the next step. Click Next and then Create Role. 4. Create and attach IAM policies asterisk. We need to create 2 IAM policies. Asterisk S3 bucket policy asterisk. This policy defines which actions are allowed on the S3 bucket itself, example S3 get object, S3 put object, S3 list bucket. Asterisk KMS key policy asterisk. This policy defines which actions are allowed on the KMS key, example KMS encrypt, KMS decrypt, KMS generate data key. Asterisk S3 bucket policy asterisk. Create a file named S3 bucket policy.json with the following content. Replace your unique bucket name and ARN AWS IAM 12345678901 role /S3 access role with your actual bucket name and the ARN of the IAM role you just created. Apply the bucket policy to your S3 bucket. Asterisk KMS key policy asterisk. Important asterisk KMS key policies are additive. The default KMS key policy created when you make a KMS key allows the key administrator to manage the key. We need to add statements to allow the IAM role to use the key for encryption and decryption. Option 1, modify the existing key policy, recommended. First, get the existing key policy. Now, edit key policy.json and add the following statement to the statement array. Replace ARN AWS IAM 12345678901 role /S3 access role with the ARN of your IAM role. Update the key policy. Option 2, create a separate managed IAM policy asterisk. You can also create a separate managed IAM policy for KMS key permissions and attach it to the IAM role. This approach can be helpful for managing permissions more granularly, but it's generally simpler to modify the KMS key policy directly. Create a file named kmskeypolicy.json with the following content. Replace your _KMS key _ARN with the ARN of your KMS key. Create the IAM policy. Asterisk attach the policies to the IAM role asterisk. After creating either the S3 bucket policy and / or the KMS key policy, or an equivalent managed IAM policy, attach them to the IAM role. If you modified the KMS key policy directly, you don't need to attach a separate KMS policy to the role. If you created a separate KMS IAM policy, option 2 above. In either case, you'll need to attach a managed policy or create an inline policy granting access to S3. Create a file named s3accesspolicy.json and attach it to the role. 5. Grant user access to assume the role *. Now, you need to grant your IAM users the permission to assume the IAM role you created. This is done by attaching a policy to the user. Create a file named assumeRolePolicy.json. Attach this policy to the IAM user, replace your _IAM_user_ name with the name of the IAM user. Alternatively, you can attach a managed policy that grants the user STS assume role permission to the specified role. 6. Test the configuration *. Now it's time to test the setup. Assume the role *. First, configure the AWS CLI to assume the IAM role. You'll need the IAM role ARN. This command retrieves temporary credentials for the assumed role and sets them as environment variables. Make sure JQ is installed. JQ is a command line JSON processor. You can install it using your system's package manager, example apt-get install JQ, brew install JQ. Upload a file to S3 *. Download the file from S3 *. Verify encryption *. Check the S3 object metadata using the AWS CLI or console. You should see the SSE algorithm set to AWS KMS and the KMS key ID set to your KMS key ID. Look for the server-side encryption, SSE KMS key ID, and encryption fields in the output. If you can successfully upload and download the file without errors, and the object is encrypted with your KMS key, then the configuration is working correctly. Troubleshooting * access denied errors * double check your IAM policies and KMS key policy. Ensure that the IAM role has the necessary permissions to access the S3 bucket and use the KMS key. Pay close attention to ARNs and resource names. KMS key policy errors * verify that the KMS key policy allows the IAM role to perform the KMS encrypt, KMS decrypt, KMS generate data key *, and KMS describe key actions. CLI configuration * ensure that the AWS CLI is properly configured with your credentials and region. Globally unique bucket names * remember that S3 bucket names must be globally unique. KMS key region * the KMS key and the S3 bucket must be in the same AWS region. Security best practices * least privilege * grant only the necessary permissions to users and roles. Avoid using wildcard permissions, * whenever possible. Principle of least authority * design your security architecture so that each component has only the authority required to perform its specific function. Regular key rotation * rotate your KMS keys regularly to reduce the risk of compromise. AWS KMS supports automatic key rotation. Monitor and audit * monitor KMS key usage and S3 bucket access logs to detect and respond to any suspicious activity. Use CloudTrail for comprehensive auditing. Use IAM conditions * use IAM conditions to restrict access based on factors such as IP address, time of day, or MFA status. For example, you can use the AWS Secure Transport condition to ensure that only HTTPS connections are allowed. You can also use conditions to restrict KMS key usage to specific S3 buckets or objects. Encrypt data in transit. In addition to encrypting data at rest with KMS, also ensure that data is encrypted in transit using HTTPS. Multi-factor authentication, MFA. Enforce MFA for IAM users who have access to sensitive resources. Avoid hard-coding credentials. Never hard-code AWS credentials in your code. Use IAM roles or the AWS Secrets Manager to manage credentials securely. Complete example script, bash. This script automates the entire process of creating the resources and configuring permissions. Important *. Replace the placeholders with your actual values. Running the script *. 1. Save the script to a file, example setup_s3_kms.sh. 2. Make the script executable, mod plus x setup_s3_kms.sh. 3. Run the script, /setup_s3_kms.sh. This script automates all the steps outlined in the tutorial. After running the script, follow the testing steps to verify the configuration. Remember to replace the placeholders with your actual values. Make sure the AWS CLI is configured with an account that has permissions to create and manage IAM roles, policies, KMS keys, and S3 buckets. This comprehensive guide should help you securely grant users access to your KMS encrypted S3 buckets. Remember to adapt the IAM policies and KMS key policies to your specific security requirements. Good luck.